Hi, I'm Mandana Moshrefzadeh, representing towards a distributed digital twin of the agricultural landscape. This is a joint work with my colleagues Thomas Machel, David Galkestetter, Dr. Andreas Danauber, and Professor Thomas Kolbe. Agricultural landscapes form a complex system of interacting and changing elements. They involve stakeholders from varying disciplines, each with their own resources, perspectives, role requirements, and so on, who need to closely interact with each other. To help stakeholders establish a common understanding of the landscape and its component, in order to reach coordinated decision making, we should make the resources available to them in a form that meets their requirements. This requires integration of scattered information from distributed resources. To do so, we often face two main challenges. The first is lack of transparency. Different stakeholders have different information about the same real-world objects, but they typically do not know what data is available from others. The second challenge is the data integration in a multidisciplinary and distributed environment. Different stakeholders do not always define and refer to a specific real-world object in the same way. This makes integration of information difficult and causes problems when linking the data of multiple actors. To address these challenges, we introduced the notion of distributed digital twins of the cultural landscape, which aims at optimizing the data integration process as well as the whole process of stakeholder engagement required in any geodesign process. This is part of the concept of Smart Rural Area Data Infrastructure that we have developed. SRADI is a multidisciplinary information infrastructure which handles various stakeholders, multiple applications, and distributed information resources. Interoperability is an important aspect of SRAD achieved by using international standards such as the ones from Open Geospatial Consortium. More importantly, SRAD is not a single platform but rather an infrastructure of the various platforms and resources. The SRAD concept consists of three main pillars: the actors or stakeholders from various disciplines, the applications which form an interface between actors and the other components, and the other components put together which make the distributed digital twin. Here I focus on the catalog component, which is the core component of the distributed digital twin. It establishes semantic relations between diverse distributed resources. Unlike typical catalogs in, for example, spatial data infrastructure, it manages not only data sets and services, but also individual physical things. It also manages stakeholders and organizations. So, what's special about our catalog? Information resource types are specialized. This means that our catalog assembles more diverse resources relevant to distributed digital twins of agricultural landscapes, such as online services and applications, datasets, software, projects, methods, and also physical things including landscape objects, devices, or even animals. By explicitly defining the types of a resource, we add specific semantics related to the digital twin of the agricultural landscape, which improves the structuring and retrieval of information in the catalog. Another feature is the links between resources. Relationships between resources of the distributed digital twin and with external resources can be represented and specialized by three different types: child of, depends on, and links to. Here is an example. Imagine these are land parcels where some agricultural research experiments are carried out. Let's have a look at one of these parcels. In the catalog, this parcel is registered as an individual entry with the resource type landscape object, and it is owned by the faculty administration. Some additional information such as geometry is also given for this entry. For the same parcel, Two datasets owned by two different chairs exist. They are presented by two additional catalog entries of type dataset, which have their own corresponding owners. Here comes the interesting part. These are linked to the catalog entry of the land parcel using outgoing relationships of type depends on, which means these two resources are dependent on this particular land parcel. In addition, there is a soil quality sensor installed on the land parcel that belongs to another chair. This resource has the type device. The sensor data from this device are stored in a sensor data platform operated by the Agricultural Research Center with the group type online service. Now the resource representing the sensor device is linked both to the land parcel and the sensor data platform, which shows the linkage of independent resources. Please note each organization manages the access permission related to their own resources. Now, a short wrap up. Information on real-world objects in agriculture is distributed among various stakeholders and systems. Zaradi manages this distributed information by providing a distributed digital twin of the agricultural landscape. We developed a metadata supporting management of distributed information resources with different kinds of data, format, ownership, privacy level, etc. Due to its unique ability to link landscape objects and owners of information on these objects, the digital twin of the agricultural landscape can also improve data preparation and stakeholder engagement within geodesign processes. A digital twin can only be created if the components are able to incorporate. Communication and data modeling is therefore based on open standards such as the ones from ISO, OGC, and W3C. If you would like to see more, I prepared a short demo video of our catalog instance so that you can see how it functions. Thank you all for your attention.